Hello friends, Mr. Burrell here. We're nearing the end of Unit 4, the second section that we've been discussing on polynomial functions. So far we talked about a lot of different kinds of polynomial functions, specifically in this unit. So far at the beginning of this unit we talked about factoring quadratic functions. So factoring functions that look like this, ax squared plus bx plus c equals 0. We talked about some different methods of factoring those types of quadratic expressions in order to be able to solve those. That's what we're all about in this unit, is solving polynomial functions. Specifically, we know how to solve, so far, quadratic functions. We also talked about the quadratic formula and using the quadratic formula to solve quadratic functions. Next, we talked about polynomial long division. So if I had a polynomial that was bigger than a quadratic, like a degree 3 or a degree 4 polynomial, I can use long division to divide one smaller factor into that larger polynomial to kind of break it down into a polynomial that's smaller or of a lower degree. We're going to kind of use both of those tools and put them together in an effort to factor and find all zeros of a variety of different polynomial functions. So that's what we're going to do here. We're going to put kind of everything together, and we're going to talk about factoring and finding all zeros to a bunch of different polynomial functions. So by the end of this lesson, this is what you'll be able to do. Factor quadratic type equations. I'll talk about what that means. Factor by grouping, and then find all the zeros of a polynomial function using factoring and polynomial long division. So factoring is something that we've done. Polynomial long division is something that we've done. We're going to put those together to find all the zeros of a polynomial function. All right. So, example 1 is factoring quadratic types. So I want you to ask yourself, what is the difference between these two problems? This problem here and this problem here. I have x squared minus 2x minus 63 and x to the fourth minus 2x squared minus 63. What is the difference between these two problems? You'll notice that they look pretty similar. This one hopefully looks pretty familiar. We've solved this kind of problem before. This is a quadratic function, and I can factor and solve this quadratic function. So let's do it. I have a, b, and c. This quadratic is in standard form. So multiplying a and c together, I get 63. And I need to find two numbers that multiply to make negative 63 and add up to b, or to negative 2. So let's list my sets of numbers that multiply to make negative 63. So I have 1 times negative 63, 2, that doesn't work, 3 times negative 21, 4 doesn't work, 5 doesn't work, 6 doesn't work, 7 times negative 9 is 63, negative 63, and look at that! 7 plus negative 9 indeed equals negative 2. So those are my two golden numbers. So I'm going to go ahead and write my factors as x plus 7 and x minus 9, each of those divided by a. And note, because a is 1, 7 divided by 1 and negative 9 divided by 1 doesn't change. And that's the factored form of this quadratic, x plus 7 times x minus 9. If I were to solve this, I'm going to set each of those terms equal to 0 and solve for x, and I get x equals negative 7 and x equals positive 9. Those are my solutions. X equals negative 7 and x equals 9. So I know how to do that. That's not terribly new information. So if I look over at this function, this is almost like a quadratic function. It has like these three terms, but notice that this is x to the fourth and this is x squared, whereas over here I had x squared and then x to the first. So just out of curiosity, I'm going to go about trying to solve this in a very similar way as I did before. So if I were to say this was a, b, and c and start factoring this as if it were a quadratic, I'd end up with these same two factors, x plus 7 and x minus 9. However, when I start multiplying these two factors back together to see if they match, when I multiply x times x, I get x squared, not x to the fourth. Well, how can I change that? What exponent could I put on each of these x's so that when I multiply them together, I get x to the fourth? Well, if I have x squared on both of these, then when I start to distribute these, multiply them back together, x squared times x squared is x to the fourth. Okay, that's good so far. x squared times negative 9 is negative 9x squared. 7 times x squared is positive 7x squared. And 7 times negative 9 is negative 63. Well, here in the middle I have two sets of like terms, so if I combine them together I get x to the fourth minus 2x squared minus 63. Huh! That is indeed what I started with. So there's a type of polynomial function that is very similar to how we would solve and go about factoring a quadratic function. Notice that I have x squared, x to the first, 2 is double 1 here, and here I had x to the fourth and x squared. Those are double each other as well. So if I have, say I have another function like x to the sixth minus 2x cubed minus 63, that function is going to be able to be factored and dealt with in a very similar fashion as the quadratic function. So that's pretty cool. That's a unique circumstance that pops up with some different kinds of polynomial functions that can be solved in a similar way to how we deal with quadratic functions. So that's example 1. From here I could continue on and set both of these equal to 0, and I'd use my square root method to go ahead and solve both those functions. Okay, so I'm going to go ahead and move on to the next one. Example 2 is factoring by grouping. So here in this term, all the ones that I've kind of previously done with quadratic functions and the quadratic types earlier just on that previous slide they had 3 terms. We had like an ax squared plus bx plus c situation. I had 1, 2, 3 terms. Well, now I have 4 terms. I don't know exactly what to do with 4 terms. So when I have 4 terms, my first method, my first go-to is going to be factoring by grouping. And I'm going to explain what that means here. So first thing when I have 4 terms is I'm going to group this polynomial, which means I'm going to split the polynomial into 2 groups. The first 2 terms and the last 2 terms. So notice here there's 1, 2, 3, 4 terms. So if I group the first 2 terms and put around a set of parentheses around them, and group the second 2 terms and put a set of parentheses around them, I get this expression right here. So I'm going to just divide these 2 polynomials into 2 separate groups. So that's the first step. That's why it's called factoring by grouping. Second step is factor out the greatest common factor. So what do each of the 2 terms share? So I'm looking at each of these groups separately. So say I scratch this out for a minute. If I was just looking at the first 2 terms, I want to see if there's a greatest common factor just between those 2 terms. So let's check it out. I have x cubed and 3x squared. X cubed and 3x squared. If I divide those out into their prime factors, I get x times x times x. 3x squared is 3 times x times x. You notice what I have in common is 2 x's here, 2 x's here. So I'm going to take out an x squared out of both of these terms. And what I have left is x and 3. So x plus 3 is what I have left inside the parentheses there. So then I've factored out the greatest common factor from the first group, the first 2 terms. Now I'm going to focus on the second 2 terms, the second group, negative 4x minus 12. If I break negative 4x and negative 12 into their prime factors, both of them have a negative in there, so I'm going to write negative 1. And then 4 is 2 times 2, and then I have an x. And then on this next one, 12 is 2 times 2 times 3. I knew that because I broke 12 down into its prime factors using this little factor tree, 2 times 2 times 3. So since those are the prime factors of those 2 terms, I'm going to look for what's common. I have a negative 1, a set of 2's, and a set of 2's. So that means I can take out of both of those terms a negative 4. And when I take out that negative 4, I have left an x and a 3, which gives me x plus 3. So notice here, I split my polynomial into 2 groups. I factored out the greatest common factor of each group. And now I have x squared times x plus 3 and negative 4 times x plus 3. Notice x plus 3 is now a common factor in both of those terms. So Here I had two terms. I took a greatest common factor, I put it in front, and then wrote what was left. So if this now, x plus 3, is a common factor between both of these terms, I'm going to take x plus 3 and I'm going to write it out in front, x plus 3, and write what I have left in the second set of parentheses. What I have left is x squared minus 4. X squared minus 4. So notice now I have two different factors, x plus 3 times x squared minus 4. So let me move on to the next page real quick. So I've determined that the greatest common factor between both of those terms was this x plus 3. So the reason when I factor by grouping, how I know that I'm going to be successful in factoring by grouping is when the terms that fall into these two parentheses match. If that is common, then I can finish and continue to factor. I rewrite that factor in front in parentheses, and then the two terms that were left, in this case x squared and negative 4, I write in the second set of parentheses. So I have x plus 3 times x squared minus 4. And then I could continue on. X squared minus 4, if you remember from our last lesson, that's a difference of squares. So I could write this as x plus 3 times the square root of x squared is x, the square root of 4 is 2, and then one sign's a positive and one sign's a negative. X plus 3 times x plus 2 times x minus 2 equals 0. Now I could solve this. I could solve this, I could draw approximately what the graph looks like, and I know how many solutions it has. 1, 2, 3. And now that I have these three factors multiplied together set equal to 0, I can find each of those solutions. In this case, those solutions would be negative 3, negative 2, and positive 2. When I set each of these terms equal to 0, I get those solutions. That's pretty cool. Okay, so now let's take a look at this problem right here. So I have x squared minus x minus 12. Focus on this problem right now. I have x squared minus x minus 12. So this is a quadratic function. I'm going to go ahead and use the methods that I already know about factoring in order to factor this quadratic function into two factors. So in order to do this, here's my a, here's my b, here's my c. So I need to find two numbers that multiply to make negative 12 that add up to negative 1, because a times c is negative 12, b is negative 1. So I'm going to go ahead and recognize that 3 times negative 4 is negative 12, and 3 plus negative 4 is negative 1. So 3 and negative 4 are my golden numbers. So if I went on to continue factoring, I write my factors out, I'd have x plus 3 and x minus 4 there, divided by 1. Each of those factors would be divided by 1 because a is 1, but dividing by 1 doesn't change anything, so I'm left with x plus 3 times x minus 4 equals 0 here. And I could finish solving this. So that's the method of factoring that we've learned in Math 2 and that we've continued to use in Math 3. But I want to show you something. I want to show you how we could use, if you wanted to, factoring by grouping to solve this quadratic. We're going to use factoring by grouping to solve this quadratic. So right here, I found my two numbers that multiplied to make negative 12 and added up to 1. They were 3 and negative 4. Here, I have split this negative x. I've unsimplified those like terms that would make that negative x into 3x minus 4x. 3 minus 4. Because notice if I were to combine these together, I'd get negative x back again. So I haven't changed this equation already. I've just kind of unsimplified this middle term and split it into my golden numbers, 3x minus 4x. Well, now, this is going to look very similar to the problem we just did. I could split this function into two groups. Split this polynomial into two groups. In the first group, I could take a greatest common factor of x, and I'd be left with x plus 3. X times x is x squared. X times 3 is 3x. In the second group, I'd take out a negative 4 like I did before, and I'd be left with an x plus 3. Well, since these two parentheses are the same, I can bring that out in front, x plus 3, and then I'd be left on the inside of the parentheses, x minus 4. X minus 4. And notice that I get the exact same thing. So the factoring method that we've already used, that's the method I'm going to continue to use. But recognize that with these quadratic functions, you can also solve them using factoring by grouping, using this same method, factoring by grouping. So this just goes to show that there's lots of different ways, there's lots of these different patterns and methods that you'll see in math that you can solve these different problems. I think that's pretty awesome. So I'm not going to dwell too hard on that. We know a way to factor quadratics already. If you really like this factoring by grouping method and you get really good at it, do it. Do it. So, the last example that we're going to talk about. So up here it says you can also use a graphing calculator to find one zero of an equation and then find the rest through long division. So I have f of x equals x cubed plus 7x squared plus 2x minus 40. So real quickly, I'm going to go ahead and take us to Desmos, and I'm going to graph this function for you. What was it again? We had we had x cubed plus 7x squared plus 2x minus 40. X cubed, plus 7x squared plus x cubed plus 7x squared plus 2x minus 40. Plus 2x minus 40. Okay. So I just graphed this equation. X cubed plus 7x squared plus 2x minus 40. And in the problem, I told you that one of the solutions to that function was positive 2 right here. It was positive 2. And alas, look, at positive 2, I have a solution, positive 2. Okay. So I'm going to go back in here. So I told you that I'm going to give you one solution, x equals 2. And what I want us to do is we're going to find the rest of the solutions by using long division. Remember, in long division, if I had a factor out here, x blah blah blah, I can divide that factor into this large polynomial. We've talked about this already. We've done long division. Well, this isn't a factor, this is a solution. A factor is when I have like x minus x plus or minus something else set equal to 0. Well, if my solution is 2, x equals 2, and I subtract 2 on both sides, I get x minus 2 equals 0. So if my solution is 2, my factor is going to be x minus 2. That's what I'm going to divide into this polynomial. So let's do this. This is long division. Let's rack our brain to last lesson. Let's use long division to divide, to simplify, to factor this polynomial. So x into x cubed, what times x gives me x cubed? Well, x squared. I'm going to write that above the x squared. X squared times x squared times x is x cubed. X squared times negative 2 is negative 2x squared. So I multiplied. Now I'm going to subtract or change signs. It's 0. 7x squared plus 2x squared is 9x squared. I'm going to bring down my next term, positive 2x. I'm going to start again. Whoops, that was a bad line. I'm going to start again. What times x is equal to 9x squared? Well, that's going to be a positive 9x. 9x times x, 9x times x is 9x squared. 9x times negative 2 is negative 18x. Subtract or change the signs. This is 0. 2 plus 18x. 2x plus 18x is 20x. Drop down the negative 40, and I start again. What times x is equal to 20x? Well, that's going to be a positive 20. Now I'm going to multiply 20 times x and 20 times negative 2. 20 times x is 20x. 20 times negative 2 is negative 40. See what's happening? See what's happening? When I subtract or change signs, 20x minus 20x is 0. Negative 40 plus 40 is 0. What times x is equal to 0? 0. I'm done. My remainder is 0. X minus 2 divides perfectly into x cubed plus 7x squared plus 2x minus 40. So, this function, x cubed plus 7x squared plus 2x minus 40, I could rewrite as x minus 2 times by x squared plus 9x plus 20. X minus 2 times x squared plus 9x plus 20 gives me this polynomial right here. Okay, so I've narrowed it down by one more step. X minus 2 times x squared plus 9x plus 20 is equal to 0. Well, I'm still not factored all the way. I'm not completely done. I still need to find the rest of the solutions. But now I have x squared plus 9x plus 20. This is a quadratic function. I can solve this one. I don't have to do polynomial long division. I can solve this one. So, if I have x squared plus 9x plus 20, here's a, b, and c. I need to find two numbers that multiply to make 20 and add up to make 9. What two numbers multiply to make 20 and add up to 9? Well, I have 1 times 20, 2 times 10, 3 times nothing, 4 times 5. Well, 4 times 5 is 20. 4 plus 5 is also 9. So I'm going to go ahead and write those two factors like this. X plus 4 and x plus 5. I write each of these terms over 1 because that's the a term here. But because 4 divided by 1 and 5 divided by 1 doesn't change anything, I can just leave those out. And then I still have this factor out in front. X minus 2. And that's all set equal to 0. So I've split this function down. This was a cubic function. And I split it down into 3 different factors. 3 factors. X minus 2 times x plus 4 times x plus 5. And I don't have any like squareds or anything left. So I'm going to set each of those terms equal to 0 to find what the solutions of this function would be. So if I set x minus 2 equal to 0, x plus 4 equal to 0, x plus 5 equal to 0. If I add 2 on both sides here, I get a solution of x equals 2. I subtract 4 on both sides here, I get a solution of x equals negative 4. And if I subtract 5 on both sides here, I get a solution of x equals negative 5. I have 3 solutions, x equals 2, x equals negative 4, and x equals negative 5. And alas, if I were to go back and look at my graph here, at 2, negative 4, and negative 5, you see all those? At 2, negative 4, and negative 5 are indeed where my solutions of this function are. And if we even wanted to reflect back into Unit 3, notice how this function behaves. It's pointing down on the left and up on the right, which is what we would expect because this is a cubic function with a leading coefficient that's positive. Blown away. So, here we used what we know about factoring and polynomial long division in order to break a larger polynomial, given just one solution, into its individual factors and to solve. So now we have all the tools in our tool belt after we've talked about these 2 units of polynomial functions. I have all the tools in my tool belt to be able to solve a huge variety of different polynomial functions. So by the end of this lesson, hopefully these are the things you understand. I hope that you're able to factor a variety of quadratic type equations, factor by grouping, and then find all the zeros of polynomial functions using factoring and polynomial long division. We have lots of tools in our tool belt. At the end of your guided notes is kind of a page we'll review in the next lesson with all kind of the different types of polynomial functions as a reminder of how to be able to solve each of them. So I hope this was helpful. Please reach out to me if you have any questions whatsoever, and I hope that you enjoyed that video as much as I did.